professional prep video. So in this video, we're going to begin the conversation on integration. So integration and derivatives are the two big operations in Calc 1, and we've covered derivatives. So if you have any questions on that, please send us an email. We're now going to begin the discussion on integration. So today we're going to start out with instead of explaining the whole integration thing, that can get really confusing. This, by the way, is an integral sign. This is what you'll see to evaluate integrals. This is the integral from a to b of, and then whatever you put here. But we're not going to go over that definition fully quite yet. What we're actually going to do is we're going to get started with a very important part of integration called Riemann Sums, and this will be a good lead into the actual integration symbol, as you see here, or sign I should say, and we will certainly go over that, but we're going to start out with Riemann Sums, so that not everyone is confused here, because Riemann Sums won't be too confusing, but they're actually very important in this integration unit. So let's go over that so we don't get completely confused down the line. So there's actually quite a few. Let me start by explaining the scenario first, actually. So say that we have someone's out on a run and for 11 hours. And so they have we're given their speed at periodic times. At time 3 hours, their speed is 6 miles per hour. At time 6 hours, their speed is 9 miles per hour. We're given that periodic intervals and check-in points for that. And we have their speed in miles per hour. And we want to approximate the total distance traveled by them from time t equals 0 to time t equals 11. So right now you might be saying that, how are we supposed to do that? We're not given all of the points. Well, we're going to use something called Riemann Sums in order to approximate it. So we have a left Riemann sum, which we're going to go over in this video, as well as a right Riemann sum. We also have a midpoint Riemann sum, which we will be going over in a video to come very soon. And then we also have something called the trap method, which we will also be going over very soon. But let's start out with the basics here. So Riemann sums. We're given a table here. This is a very classic Riemann sum problem. And we need to choose a number of intervals. So let's use all the intervals available to us here. All 4 of them, from t equals 0 to t equals 3, 3 to 6, etc., etc. So that's our first step, choosing intervals. In this case, it's really up to us, because the question does not specify the number of intervals. Sometimes it will, but in this case, let's go with 4 intervals. So this might seem a little bit confusing so far, but watch me do the left Riemann sum, and I guarantee you that you will be able to do the right all by yourself. So all that we're going to do for this, a left Riemann sum. So first, what you want to do, you're going to multiply 2 numbers here. The first number you're going to multiply is the length of the interval. So let's start with the first interval, from 0 to 3. The length of that is 3. Simple enough, right? And then, which number do we choose here? We need to choose the one that is on the left. So that's the whole point of the left Riemann sum. So which of these numbers is on the left? 7. Don't use 6. You want to use 7. You'd use 6 for a right Riemann sum. So we're going to start out with 3. And then times 7 plus, now we're adding on our next interval, which is from 3 to 6. The length of that is 3 again, 6 minus 3. And like I said, this is a left Riemann sum, so now we're going to use the 6. We're using the number on the left of this interval here, which is going to be this. Plus, and now this gets really simple, straightforward from here. The length of this interval is 1, because 7 minus 6. Number on the left is 9, left Riemann sum. And our last interval from 7 to 11 has a length of 4, and on the left is 8. So that's all this really is. That we have just performed a left Riemann sum using 4 subintervals. And you could evaluate this algebraically, obviously, but I'm just going to leave it at this. And let's move on to the right Riemann sum. So at this point, you probably know exactly how to do this. So let me write this out. Our lengths of intervals are going to be the same since this is the same table. It's just that the numbers we use are going to be a little bit different, what we multiply by, that is. So this is a right Riemann sum. So now we use the number on the right, which is 6. So we get 3 times 6. Plus the length of the next interval is also 3, with the number on the right being this 9. Next we have length 1, number on the right being an 8. And last but not least, our 4th interval, length being 4, with the right Riemann sum being also 4. And again, you could evaluate this, but that's the right Riemann sum approximation for this table. And there you have it for left and right Riemann sums. We'll be going over midpoint Riemann sums very soon. You actually could not use this table for a midpoint Riemann sum. But for now, that's all that I have for you for this video. Let us know if you have any questions. We know this can be, this is our first step into integration, so try to take it slow, but that being said, let us know if you have any questions, and if not, we will see you next time. Have a great day, everyone. Thank you.